broadcasting live from warm, sunny. Hi, everybody. This is Charles Hoskinson, Singapore. I decided to make a very brief video about a few things while I have some time because I'll be traveling to South Korea next, and then after that, Vietnam. And I'm not so certain when I'll have some free time to do this. Just spoke today at the World Blockchain Conference here at the Marina Bay Sands. Lovely hotel, pretty crazy pool, and had a great time having a conversation with Mohammed and a lot of the other people over there. Anyway, I just wanted to give a brief update about the upcoming Cardano update 1.3 and also talk a bit about Prometheus. I kind of let it slip that we're working on something Rust related, and I wanted to give some more details about what we're doing there and kind of also talk about smart contracts for a bit. Okay. So 1.3 is currently in QA. We're having a good time with it. It's moving through quite nicely. We caught a few bugs here and there. So our QA process is definitely working. It's still a little slow for my taste, as a lot of things are still manual, and we're working very closely with allied testing to automate as many things as we can over time. But 1.3 is looking pretty good, and we're really excited to see 1.3 have a massive improvement to network performance. So a lot of people are having trouble connecting to network and trouble getting blocks quickly. We should see a big speed up there, and primary bottlenecks will probably be no longer on the wire protocol side, but rather in the block processing side. So we're also working pretty hard to correct that. We've been going through a pretty heavy-duty refactoring of our core, kind of taking it down from a monolith to a more library-derived architecture, more like service-oriented. That's a long process, and there's a lot to do. Unfortunately, if you look at our dependency graph and how things are constructed, it's Cardano's grown to be a very complicated, in some cases unnecessarily complicated piece of software. So look for the update in August, early to mid-August, hopefully around the 7th, but we'll find out when exactly that's going to ship. And I'm sure you guys are going to really like Cardano 1.3 and the new version of Daedalus. Now, looking forward, 1.4 is still on schedule. It's probably the most significant update we've done since 1.1, and 1.4 is going to have a lot of infrastructure code and a boatload of changes. This update is going to be a little different than the 1.3 update. So when you install 1.3, you'll get notified and you just click upgrade, or you'll download it manually and install over. It's a pretty simple process. When you install 1.4, because of the way that we're doing the new data layer of the system, you may have to restore your wallet to actually restore into the new system. So restoration is going to work a lot faster than restoration works right now, but that means that the installation is going to be a little bit longer than the installation for 1.3. Not longer in terms of 10 hours, but longer in terms of maybe like 30 minutes or an hour or something like that, depending upon PC speed and so forth. But that's only needed to be done once, and then moving forward, that new data model is going to be there. Anyway, so 1.4 is pretty big, and we're working real hard towards it. I think there's 79 items that we're thinking carefully about how we pull them into 1.4, and about 29 or so have been finished, and we're moving real fast towards the remaining 50. Okay, so there's been a huge amount of requests for very portable code. We've had a lot of people come to us and say, we'd like to construct a light client or mobile client. We'd like to construct a browser-based wallet, or we want a library with Cardano functionality so that we can do things. And we said, boy, that's a good idea. Unfortunately, Haskell, as good of a language as it is not exactly the best language in the world for portable, lightweight code. There are other languages, for example, Rust, which are much, much, much better. So after having a lot of discussions, we said, let's fund a parallel development team and kind of incubate it within IOHK and build up a library of functionality that people can use for mobile wallets and light wallets and embeddable devices and for Intel SGX and so forth. So we call this collective aggregation of code Project Prometheus. We'll probably give it a sexier, more interesting name, although, it was a pretty good movie. I wished it was a little bit better. David was a good character. Anyway, we'll give it a sexier name at some point, but basically it's a new project. We've been running it now for about 3 months internally, and we've got it to a point where we think by September we might actually have a full command line client working with Rust code, and developers can take that code and use it and embed it within their devices. We've also been testing it on Android, and it works pretty well, and it's going to be put into a product that we'll be making an announcement come August 15th. So I won't spoil that announcement, but it's going to be a pretty cool product, and I think you guys are going to be very, very happy with it. And if you're having issues with Daedalus, I think this new product is probably a good solution for you guys. Anyway, that's Prometheus in a nutshell. It's got a relatively small team led by Vincent Henquez. It's very concise, and so far it's been really a joy rebuilding Cardano and Rust. It's also opened up a lot of questions about certain protocol design decisions that were made in the past by prior teams, and potentially when and how should we change those. For example, it would be nice to have a slightly more standard network protocol. We've been experimenting using HTTP. It'd also be nice to change out the CBOR format that we're using, because that's a bit heavy, unnecessarily so. So as we move beyond 1.4 and we start having meaningful discussions about Shelley and what Shelley's going to bring when that hard fork comes, we probably will switch out some things that were just not well designed in the beginning and bring them back into more industry standard or more optimal status. So that's pretty much it on the Prometheus side. It's been a real fun project to kind of incubate. It feels like a parallel team, almost when the Mac team was created and they still had the Apple II team, and we've really enjoyed doing some cool things. So look for that soon, and we'd love to have you guys play around with it. 1.4 on Cardano, going back to that, is also going to be probably using the entire 19 endpoints on the V1 API. We're working hard on Daedalus to connect to it. Currently, we're only consuming one of the 19, and our hope is to cover all 19. The remaining endpoints are being still called from V0. It's a good way of verifying and testing all the quirks of V1. We've already gotten a lot of comments and feedback from exchanges about things that they'd like to see or ways of extending those APIs to meet some specific needs. But overall, we're very happy with the construction that we have there. Okay, a bit about smart contracts. We've hired a guy, Mark Annabali, and Mark's a real experienced entrepreneur and a real experienced product manager. And as we get closer to the Yella testnet launch, we now will have 2 testnets running with smart contracts, the KEVM, which has already been running, and the Yella testnet. At the moment, the surface language that we're using to test things is Solidity. We did that on purpose because there's a large amount of Solidity code that can be ported over, good test vectors for it, good libraries for it, and also a large group of smart contract developers that are well trained with Solidity to go ahead and play with our systems. And we've gotten a very good response from them. So anyway, we're going to continue doing that for a little while, but I would like a better surface language than Solidity. And so we've batted around the ideas of porting perhaps JavaScript to run on Yella. And this is before we get access to other languages through semantics-based compilation. It's kind of a trade-off where you have to make a decision: is it worth diverting resources to build a compiler to target another language towards our system, when in a reasonable time frame we'll have SBC to do that for us for all K-defined languages. Maybe we will, maybe we won't. We're still having that discussion, but I'd like at least one more surface language for people to write smart contracts in other than Solidity. But for the purposes of July and August and the foreseeable next few months, Solidity is going to be the language people are going to use to touch Yella and to touch KVM, unless you want to write things in EVM assembly or in Yella assembly, which in the Yella case it looks a lot like C, so it's at least programmer friendly. In the EVM case it actually looks like assembly, so good luck with that. Have fun with it. So we wouldn't recommend that. Okay, so anyway, what Mark is doing is Mark is looking at how people use smart contracts, how industry uses smart contracts, what's materialized and developed, and also some other alternative models, like things like liquidity and Michelson, and what's being proposed with simplicity, and there's probably a dozen other to examine. And we're trying to get a good sense over the next 6 months to a year of things we ought to do to build up a Cardano standard library that's very developer friendly and will have a lot of utility and use. There's also things outside of the cryptocurrency space that look very interesting, like how Lua, for example, interfaces with C. Is a pretty interesting and nice model that a lot of game developers have had tremendous fun exploiting. And there are other models that we've learned from working with Haskell and Rust that might be quite desirable. So Mark is going to be examining these things, meeting a lot of you guys, interacting with the community, having a lot of developer conversations. We're also going to work very closely with Nico and Sebastian. Nico's the CTO of Emergo, and Sebastian recently just came on board Emergo. And he makes great videos, and he explains a lot of the topics in our ecosystem, and he's a developer himself. And so we'd like for you guys to interface with our people and let us know what you'd like, and let us know what you think the standard library should have. So just let us know about that, and we'll get something cool out for you soon. The crown jewel of our smart contract model is Plutus. We've extended the team extension a lot, from 2 to 6 and maybe up to 8. And actually, we just hired Michael Peyton-Jones. If you're a fan of functional programming, you'll probably know the name Simon Peyton-Jones. And it turns out that Michael's following in his father's footsteps and has become a PL theorist, and was looking for an interesting project. And we said, well, Plutus is kind of like Haskell, the next generation, so it only makes sense to have some of the Haskell committee reconvene. So we'll see if we can get any more of the old guys together. We're already working with John Hughes and Phil Wadler. Hopefully we can get a few other guys. And it's nice to work with Michael. He's a real smart guy. And there's a few other people who have joined that team as well that are very solid. So we're seeing good and steady progress with Plutus, and we're starting to get to the point where we're going beyond the theory, and we're going beyond a lot of really extensively complex language design questions that are being made with a lot of rigor and experience, to actually having good conversations about what the surface language is going to look like, and the developer experience, and so forth. And what does it mean to extend the UTXO model and do UTXO-style smart contracts, as that model is not popular and has yet to be done in a production cryptocurrency. It's been proposed in other places like Chain and so forth, but it hasn't actually really been rolled out yet. So it's kind of a new model, and it's something we're pretty excited to think about and formalize. Along the same token, we've had a lot of progress with our chimeric ledger and chimeric asset ideology. So this notion of a chimeric ledger or chimeric asset is an idea of an asset that can live in multiple accounting systems. So you can move from UTXO to accounts, and a ledger that has the ability to support multiple accounting systems. This is necessary for our sidechains model, because if you're using sidechains, you're going to move between systems, for example, like Ethereum and Cardano. Ethereum is an accounts-based model, and Cardano is a UTXO-based model. So you have to have a notion of value in both systems, and you have to be able to move assets between the systems while conserving that value. You don't want a situation where their accounting systems are somehow incompatible and you lose value or something like that. So it was very important for us to think carefully about, can you have assets kind of transform from one accounting system to the other? But it's also exposed a more interesting research question, which is, could there exist other accounting systems that potentially are really nice to have for certain domains and certain experiences? So we use that term chimeric as basically a way of capturing the notion that a ledger has multiple accounting notions, and chimeric assets is an asset that can live in different accounting systems. So eventually what we're going to do is pull that paper that Bruno Paleo, one of our computational logicians, wrote into the formal spec that we have for the UTXO model. And then when these things are combined together, we can prove some interesting properties about them, and also look at different transaction models. For example, right now, Bitcoin and many cryptocurrencies use the notion of a sender pays model. So if Alice sends a transaction to Bob, Alice pays, Bob receives. But if you look at systems like credit cards, for example, it's a receiver pays notion. So when you swipe your credit card at the merchant, generally you don't pay the transaction fee, the merchant pays it, and in some ways remunerated through some other process. So there's all kinds of different transaction models that you can look at, and some of these have existed in other systems. It would be nice to have a bit more user programmability and a bit more rigor and theory behind options and the consequences of those options. So anyway, we're exploring that as well in that research stream, and we're going to begin pulling that in, and it's deeply connected to Plutus, because Plutus will be the vehicle to launch a lot of these types of assets and give these assets life and functionality and so forth. Cardano will have its own ERC20 style standard. At the moment, we can support ERC20 through both Yella and the KEVM. In fact, it's a better experience deploying ERC20 on Yella, and we should actually have some tutorials and content showing how to do that. in particular showing how you can avoid things like the DAO error just by having the compiler catch it as opposed to living it. So yellow is pretty cool stuff, and I think you guys are really going to like a lot of our tutorials and the testnet website and content that we have, and we'd love to get your feedback there. That said, we can do more with SL, and it would be nice to build some more primitives into SL than Ethereum has, because issuing tokens is just such a common practice these days, and it's something that we believe is really fun and users love. So we should build better support for these types of things in. So one last thing along that thought, sidechains. We've made enormous progress on sidechains. We've really done some great work there, Dionysus and Peter Ghazi and others, and we'll have some papers coming out soon about them. It's taken quite a bit of time to get to a model that we feel pretty comfortable with and get the theory where it needs to go. It turns out the proofs for these things are really touchy, and they require a lot of careful thought. Now, and this is one of those principles versus pragmatism trade-offs, where on the principles side, you really would like for these things to be fully proven and to have peer review before you even touch the code. On the pragmatism side, once you get to a certain degree of assurance that the protocol is right, you'd like to implement the protocol. So you have to kind of know where to cut, and you have to kind of know when to say, okay, that's good enough, and let's start building it, and have the theoreticians keep worrying about getting the proofs to be perfect and concise and nice and peer reviewable and so forth. So at the end of August, we're planning on having a lot of our scientists and engineers meet together, and two of the topics that they're going to be discussing are going to be formalization of Ouroboros Genesis, and basically everything that's required to kind of do what we did with the UTXO model, the wallet's formal specification for Genesis, and actually build a prototype derived from that, and also sidechains formalization. And our hope is to actually start demonstrating sidechains by connecting some centralized chains to Cardano as like a permissioned computation ledger. That model is something we think will become very common with the notion of exchanges. So a use case that could happen in the next few years is, instead of sending transactions to exchanges as an open address on an open network, like you're sending your Bitcoin to an exchange's Bitcoin address, you'd be issuing a sidechain transaction and sending it to a permissioned ledger that the exchange controls. Now, why would you want to do this over a normal transaction? Well, because you're already trusting the exchange with your asset, so you're kind of having the worst of both worlds. You're paying the price of decentralization and all the security risks that it has, but you gain none of the benefits because someone else is in control of your money because they possess the private key. By being able to send it to a sidechain, then what you could do is bake into the sidechain business logic that could allow the exchange to protect itself in the event that a hack occurs or someone tries to steal the money and so forth. And that would map very nicely onto how the exchange stores funds and how the exchange recovers from disaster. So incidents like CoinCheck could be significantly less damaging. And also, you would still gain all the benefits of having a blockchain. For example, you can bake in business logic that could prevent front running and other such things. Whereas that's much more difficult to do on open networks. So we're really excited to kind of show that that model can exist, this idea of a centralized sidechain that would you'd be able to send assets to and back, and to show the firewalling property and the other nice properties we have with our sidechains papers. So look for that. It'll come, and hopefully we can have some sort of demo before the end of the year, and we can perhaps even use it as a way to roll in some smart contracts a little early, potentially even pre-Shelley, depending upon how quickly these things roll out and how difficult it is to actually specify the sidechains protocol that we have. So that's a lot of the work we're going to be doing in August. Now, one last thing, Ledger support. A lot of people are talking about Ledger. They're really excited about it. So that's another one of those, where do we cut the rope style work streams. We have some new address structures which are much more concise, and we have a new HD wallet scheme that's rolling out soon. The first product to support that will not be Daedalus. You'll see something soon that will have something interesting about that, and it'll be backported into Daedalus. So there's an open choice of whether we use the old key scheme, the old address scheme with Ledger, or the new scheme. In any event, this new product will probably, because of its architecture and its nature, be able to use Ledger before Daedalus can. So we'll do a separate update on that, and we'll have a nice conversation about it. But there's going to be at least 2 Ledger updates. One will likely be a Ledger update specifically for Daedalus. The other will be a ledger update to cover all of the other functionality that we'd like to see, namely cold staking. So this is the idea where you leave your spending keys on Ledger. They don't actually touch the internet. They're not hot. But then it creates a proxy key that is then imported into Daedalus and to other wallets as a standard, and then you can use that to delegate from. So you have a delegation key that's separate from the cold key. You can leave your keys cold. No one can steal your money. And even if your delegation key is compromised, you can always reconnect your ledger, generate a new one, and void the old one without any loss of funds or security. So that functionality requires a little bit more programmability, and it's part of the Shelley workstream. So it won't delay the Ledger workstream because we'll simply just update Ledger and work with them to do that. But it is an interesting question of exactly how much work is going to be required on the Ledger side for that, because the microcontroller is very primitive and necessarily so. You don't have a lot of capabilities on a device. The more you have, the bigger your attack surface is. So you want to just have just enough to do what you want to do in a very well understood sandbox to play in, so you can verify that that sandbox is secure. But it also means it's harder to add new features, especially complicated features. But we think the way we've designed things, it's going to be pretty easy to port in. So look for that as well. We'll make a separate announcement about exactly when Ledger support is coming. And it's one of our most, if not the most requested features. And we're pretty excited about it. And I think you guys are going to have some great times with it. Multi-sig is another challenge, and that's another one of those, well, we have a pragmatic way of doing multi-sig, or we can do a more principled way of doing multi-sig. So multi-sig can either be done in a pragmatic way, where you use a trusted server to create accounts with parties, so it has some notion of state, and then it allows you to kind of alert people that they have a signature that's pending. So let's say you have a 2 of 3 signature, and you're using something like Copay. How that model works is all 3 of those signatures generated that keychain, and they know of each other because they registered first with Copay. Then when one of the signatories makes a request, it will send a message, push, to those other 2 signatories and alert them that they have a pending transaction. It does not broadcast that transaction to the Bitcoin network until at least another one of the people signs. And at that point, then the transaction gets broadcast. So because of that out-of-band process, Bitcoin is not aware of these things. It only sees the final product. So it doesn't have to have a pub/sub protocol or any complicated logic under the hood. Now, there are other systems, like Ethereum, for example, which do have those capabilities to do this without a trusted server. So we're planning on having these functionalities built into Shelley, either on launch or a little bit later down. And if we wanted to have a truly decentralized multi-sig option, we could utilize that. Or we could release a halfway house solution, which would result in a stateful server that can help match people. So we'll have some discussions with the community, and we'll have some discussions with people about what they think is the best option, as well as our partners. And there could be a potential where we release one of these coordination server solutions prior to releasing the fully decentralized variants. I'm a big fan of multi-sig. I think it maps very well to the business logic of blockchain companies, where you have decentralized control over funds. And so I think it is very important that we have this feature. But it's a matter of, well, what's good enough for these types of features. As for Coinbase, I can't answer any questions about that. It's Coinbase's decision on how and when to make announcements. So I won't answer anything. I'm sorry, I wish I could, but that's just how it is. So that's pretty much it for the announcements. Covered Prometheus, covered multi-sig, covered Ledger, covered Plutus and smart contracts. Yellow testnet's still on schedule. Code is frozen, and we're just getting ready to launch it. Everything's looking pretty nice. Content is looking pretty nice. We're very happy with that. And 1.3 is on schedule. Things are looking pretty good as well. 1.4 is also on schedule, and things are looking pretty good. So overall, project is in pretty good hands. We're pretty happy with the way everything's working. I wish things were a little faster, and I wish everything was a little bit better. I still do see a lot of the help desk reports that people are sending. We get hundreds of them. A lot of cases, it's just users not understanding what to do or how to do things. But in some cases, they are legitimate bugs, and I feel really bad about that, and I'm sorry about it. I wish we could move faster, and I wish that we could solve all of your problems. Unfortunately, that's just the way software works. Even if you're trying to build great software, from time to time, people are going to have a little bit of trouble with it. So we're doing our best to try to get through that entire queue, and we're doing our best to try to create some options for people so that even if the primary experience doesn't work, people can still securely store their ADA, spend their ADA, and participate in the ecosystem. So just be patient, and a lot of things are coming soon, and hopefully that will resolve many of your problems if you are experiencing problems. If you're not experiencing problems, thanks for the faith and support, and we really look forward to working with you guys. So thank you so much for your time, and you all take care now. Cheers.